Good afternoon, guys. Today our topic is ant colony optimization. Okay, and now we are going to start. And this ant colony optimization was first introduced by scientist Macro Darigo in 1992. Okay, uh, so we can understand this ant colony optimization. First, our topic is ant colony. This is very important topic for our artificial intelligence, neural network, etc. Okay, colony optimization. So this is ant colony optimization first introduced by scientist Dr. Macro. Okay, in his PhD thesis, he first introduced this ant colony optimization. So, but the ant colony optimization, it is generally called ACO, ACO. Oh, and it was generally a computer science departmental subject, but now it is introduced in artificial intelligence also. That's why we have to know this, and this is a probabilistic technique. First, we have to know that this is a probabilistic technique. Means there is actually there is a shortest path algorithm. It is defined, and this is a probability. Okay, so it is a probabilistic. This is a probabilistic technique. Okay, and it is a mathematical problem also, and this algorithm is a member of the colony, and it is an algorithm family, and it is a swarm intelligence methods. Okay, we know this is a swarm optimization is there another topic. So it is a swarm optimization, swarm intelligence method, and by it is a bio influenced. This algorithm is a bio influenced algorithm because how a ant define its shortest path, and in through this algorithm we will know how the ant is find it the shortest path, and then how could I implement it in our mathematical algorithm. Okay, so this is a organizational idea. You may write down it, or you may note it, and this is a very important topic for this optimization techniques. Okay, in there is a various algorithm is there, but that are the member of ant colony optimization algorithm, and it is aiming to search for an optimal path. It is generally aiming to search a optimal path of a graph by which it can reach its very less time. And in our power system, say nowadays we are going for the mm, uh, mm, wireless communication. Okay, wireless communication is not it is defined by some your say your mobile network. You are working with this is communicate with this mobile but through your tower. Okay, but say this is your tower, this is your mobile tower is there, your mobile may be here, your mobile may be here, or your mobile may be here. So this path is this path is going to in this way, but through this path, through this path, through this path, here is also a tower, here is also a tower. Say this is a tower 1, this is the tower 2. Say your position is look in this position, but you are coming through this tower area of this tower. Okay, say just I'm changing the color of it. Say this is the radius of this tower. Okay, and this is the radius of this tower. Sometimes you can see in your mobile two two tower name are showing. Sometimes this is another location, sometimes another location, because two tower are you are at the border side. That's why two tower are sometimes acquiring by your mobile. But say your mobile is just in this position, just in this position. It is the border of this tower one, but you are coming to the you are want to communicate with the another mobile which is situated at the tower 2 position. Okay, but what happens, your mobile is first communicate with this tower 1 T1, T1 then communicate with this T2, then T2 will communicate with this is your mobile. Say your mobile is A and your mobile another mobile is B. So what happens, maybe your distance is very small, that is say maybe 1 km, but you are traversing so many. This is maybe a 2 kilometer, and from this tower, or say this is a 5 kilometer, and again it is coming at 2 kilometer, but because this is a defined path. But if there is a ant colony optimization, now it is coming ant colony optimization, there is no predefined structure is there. Okay, preset structure is there. Say you are in this position, so you are going to this short path communication. Maybe there is a transponder is there, maybe a transponder means satellite communication is there. Then what happens? It is send this signal to this satellite, then satellite communicate with this. Nowadays, this is the next generation communication is there. So it may reduce your communication path. It may reduce your or battery life of your device also. So this is the fundamental things of this ant colony optimization, because we are going to the shortest path. But in this situation, you can understand these things. Say you are in the tower area 1, but you want to communicate with this B mobile. This is under the tower area 2. So what happens? You have to communicate with the T1 tower 1, and then tower 1 will communicate with tower 2. Then tower 2 will communicate with this tower B, but not directly it is communicated, because because its long path will be traversed. So that's why we are going to the uh, shortest path algorithm, and this shortest path algorithm is fulfilled by this ant colony optimization. And we know there are the various algorithm, but in this is uh, ant colony optimization, the aiming is to choose the shortest path within this graph. This is the main motto of this algorithm, and that's why it is very much important to us to know this, because it is not only applicable for the communication system, it may be applied in our power system, where signal is have to send in a shortest path, at where wireless communication or the predefined communication is not occurred. Okay, and it may be applicable in the computer science department. First age in a Photoshop, there is a Photoshop, there is a age calculating devices is required, algorithm is required. They are also this image processing. They are this type of algorithm is very much important for us. Say there is a 2 point is there, which shortest path it will age, it is the image processing unit, its shortest path calculation. In this area we are using this optimization. And now the original idea has since is diversified to the solve a wider class of numerical problem. First aim is the idea is has to, as the since is diversified to solve a wider class of numerical problems, and as a result several problems have emerged and drawing on the various aspects of the behavior of these ants. Now next generation wireless is going to this. And now how it is applied. At first we have to know how ant, look, here is an ant, and it is want to know which path they have to traverse so that it can reach its colony to the food. Say if this is the ant colony, and here is some food is there. Say here is some food is there, uh, some food is there. Okay, so how they, this is the colony, how they reached over there. Look, first some searching ants are coming together to search this. Say this is ant, this is ant A, uh, it is traversing this path. In this path they, it is searching, it is going to searching it. First time it is not known to it that where the food is there. Some ant, it is going to this path. Some ant, it is going to in this path. Okay, so this is the black ant. Okay, so you know there is a, how they are communicating, they are communicating by face to face interaction, and they are communicating by its pheromone structure. First, ant colony optimization is depends on the behavior of ant by the pheromone structure. Pheromone pheromone based communication, that's why it's pheromone structure. And now you can see there is a ant, say ant, red ant, and there is a, say two ants are going to this path, and there is a black ant and there is a red ant. I am saying for the convenience, this is a B ant. Okay, so you can see the path is, this path is A and this path is B. You may treat it, rather this path is A and this path is B. Then you can understand how it is happening. This is A and this is B. Look, ants are running together by one. Okay, there no gap is there. One ant, then another ant, one ant, then another ant, one by one. It is traversing to this path. It is reach at a T1 time. Say this is reached at a TA time. Okay, and these black ants, they are one by one, just one by one, they are reached at this food, that is at the TB time. Okay, so whenever they are returning, they get this is food, but whenever they are returning, look, this B is reached faster than A. So TB is less than TB. TA means if it is taking 5 minutes, then it is taken say 7 minutes. Just assume. Now, when they are, now these ants are not there, so just remove these ants. But now when they are returning, look, these ants, when they are returning, so it will take also 7 minutes, say ta time, and it will also tb time for the returning path, for the returning part. So what happens? Because TB is less, so for the up time, this is 5 minutes, and for the down time, it is taking the 5 minutes. So totally it is taking 10 minutes. But in case of path A, say for the up time, it is taking the 7 minutes, and on the down time, it is taken the 7 minutes. So actually it is taken 14 minutes. So after the 10 minutes passing, say this is the 10 minutes passing, these black ants reach to the position over here, reach to the position over here. Say this is first. After the 10 minutes, black ants reach to the colony again. So it is dropping its pheromone. First time it is dropping pheromones. But after some time, pheromones will be also decaying. Okay, so the smell of this pheromone or concentration of these pheromones will be decaying. But whatever, it is depositing pheromone, and it is when after 5 minutes it will maybe totally dissolve. But whenever it is returning, look, whenever it is returning, then also it is depositing this green color pheromones are uh, depositing. So this is after the 10 minutes he reached his colony. So at the front of this colony he also deposits some pheromone. Why? Because he reached it. But at that moment, because this path A, the ants are just like red ants are some away from this colony, because it needs 14 minutes. So it is more 4 minutes. It's away from its 4 minutes away from its colony. So here is its position. Here is its position. But black ants just reached its position. So whenever they they throwing they spreaded their pheromones, this is far from the black. Okay, so it is because it is reach shortest time, shortest path. That's why it is taking short time. That's why it is depositing pheromone over here. So next ant, when next ants are going to start its journey, when the next ant going to start its journey, they, which path he or she, means it is a not he or she. This is a this is a insect. That's why when it starts its journey, then which path they follow? He is taking smell of the pheromone, strong pheromone of the bee path. Okay, because the black ants coming to this bee path, and it is just nearer to the colony, and that's why its pheromones, which it deposited the pheromones, it is very strong to this ant. So this is the X ant. X ant smell this path pheromones is very strong, and this path pheromone is maybe not come to it, or it is very faint. So it will follow this path. Okay, so after then it will going to the memory, it is again it is come to this path, and in this way other sand also follow this path. So this B path became the shortest path to be followed. In this way ants are following, choosing its shortest path, because ants can't measure the path. Human can measure this path, how many meter, how many times it is taken, but ants are not able to measure this path. Ants are not able to measure the time. But how it is possible that it is taking the shortest path? It is choosing the shortest path when the searching ants are returning. Their pheromones are very much stronger, and which path they are stronger, then they will follow this path, and by using this path they find that this path is very shortest, and then this path will be this selected as a shortest path. Then they all ants are following this path. So this is the ant colony optimization. Actually this is not a optimization, this is optimization by the ants. But human can find out this behavior. And first doctor and Macro Derigo in 1992, he observed this optimization, means he proposed this optimization by uh, by watching their behavior, by studying their behavior. Okay, guys, I think you can understand this ant colony behavior. If you have any confusion or queries, you may ask me. Otherwise, ant colony optimization is a very interesting optimization, but you can't say whenever the question is asked or anyone may be asked. Is it clear to you? Then I will go for the mathematical uh, presentation. Hello, if it is clear to you, then I going for the another topic.
Yes, sir, clear.
Okay, okay, thank you. Guys, now generally ant colony is given, say a ant, this is our optimization study. This is not uh, ant behavior. Okay, this is the antenna. This antenna, they are communicate and they can sense the pheromone. Okay, say this, there is a position A, there is a position B, there is a position C, there is a position D, C. So first they are going to traverse in this way. Okay, so this is a city A, B, C, D. Okay, they are traversing. So how could I go for the optimization technique? Look, first we have to know what is the shortest path among it. Say there is a D1 distance, there is a D2, D3, so many. But there is some transition rule or there or the some algorithm. So we have to know this. First, we are going to the declaration. This is R2S, TRS. What is this? Now, T is the amount of pheromone currently on the path that goes directly from city R to S. This is the city R and this is the S. So, what is the T? Is the this is the amount of pheromone deposited it in this path, that is called TS. Now, HS, H is the heuristic value. HRS, R2S, RCT and ST. It is the heuristic value uh, from this link the classic TSP application means transport application. It is chosen in to be 1 by distance, 1 by distance, RS. So if distance is higher, then the value is means its power means it is the value is lower. If the distance is small, then the heuristic value is high. Say this is if 1 by 5 km or 5 meter, then its value is less. If 1 by 2, then value is high. In this way. And this is pk, this is pkrs. This is the probability that and K will choose the link that goes from R to S. This is the probability. It can choose in this path, in this path, say this is the probability. It can choose this path, it can choose this path, it can choose this path, it can choose in this way. So 1, 2, 3, 4. Okay, it is the probability. And beta is a parameter that we can call the heuristic strength. Okay, so the transition rule is pk pkrs pkrs equal to t, that is rs t, this is the amount of pheromone and this is the heuristic value of rs to the power this beta. Okay, and divided by summation of TRS into TRC. Sorry, this is C. This is C. What is C? I am explaining this C. What is the C? C is unvisited cities. C is unvisited cities. RS is the visited cities, and R to C is which are not visited. Say this ant should be go A, B, C, D, E, F in this way. So this is reached. So we know the value. Say so that is F. This is C. Till now it is not reached. So this is unvisited value. So it is the transit transition rules for this ant colony. Okay, and where our ant is at city R and the city F is a city as yet unvisited on its tour, and the summation is over all AK's unvisited cities. This is the statement. And the global pheromone update. Another rules is there, the global pheromone update. Okay, what is this? This is AKRS is the amount of pheromone update added to the RS link by the AND key. Is the amount of pheromone added to the RS link by AND key. And now M is the number of of ants. Parameter called pheromone decay rate. Pheromone decay rate. Then ELK is the length of tour completed by ant K. So, so this is the rules that this row, this is the row, this is the row into TRS. This T is the next iteration becomes. This is the next iteration. Equal, sorry, this is the plus summation of k equal to 1 to the m and ak, this is rs. Okay, where ak is the 1 by lk, is the length of the tour completed by the ant, and it is the amount of the pheromone added to the rs link. So a is the 1 by lk. Okay, ak is 1 by lk, this related. So this is the next iteration process, and then it will going on. So this is the mathematical some rules for the ant colony optimization. We have to just remember this. in our program, if we are going for the MATLAB program or the artificial intelligence program, then we have to go for this, formula. Okay, and we have to know the algorithm only. Now we are going to the ant colony algorithm. Look, ant colony optimization algorithm. First of all, set a parameter value for the AOC. Set a parameter value for the AOC. AOC is the ant colony optimization. Then it is going. You may write down it, because actually there is a no books are available in our general market, and we are going for the some journal papers, that is published by 2020 science directed journal paper. There I get this algorithm. Initialize initialize pheromone concentration. Each region, then this is checking if it is yes. If no, then it will going to the then local optimum achieved. Achieved, and if it is satisfied, then it is stop. And if here, if this is no, if this is no, then it is going to the this state. Look, first it initialize a pheromone concentration, means per area or per drop, it will concentrate this pheromone. Then create a region for explore, means create a route map. Then it's determine the object by going this into the object, and means here is the objective function. Now check the region explored whereas it is better or not, means it is the shortest path or not. If no, then it is going to the first step, then initialize the pheromone concentration. Again it will go for the another path. Okay, but if yes, then it is repeat for all. Yes, if yes, then repeat for all. If no, then it will again create a region to explore the memory, means in the previous memory it is deleted, and again it will collect the new memory, and then it is going the first, then it is the pheromone evaporation was technique, and then it's a local optimal optimum path was achieved, and then it will stop. And in this way algorithm is uh, going to searching for the new path, whereas it can select the shortest path. Here the pheromone concentration actually it is given and by some beta value, because this is the heuristic concentration actually. Okay, and by the ant colony they are pheromone concentration. This is the algorithm and overall idea regarding ant colony optimization. Guys, if you have any question or any confusion, you may ask me. Okay, if you have no question, then I may stop here. Okay, I stop here. Thank you for listening me. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Have a nice day. Thank you.